Let's explore the fan-in and fan-out patterns in Go. This pattern helps in efficiently distributing work and collecting results using Go's concurrency features. Let's see how we can make use of these patterns. Fan-out is a pattern used to distribute work from a single source to multiple Go routines. Imagine you have one input source, and you want to process the data from this source concurrently. With fan-out, you can send data from this single input to multiple worker Go routines. As the diagram depicts, a single input is fanned out to worker 1, worker 2, and worker 3. Here is the code snippet demonstrating the fan-out implementation. We define a function called fan-out, which takes an input channel of integers and the number of workers as arguments. It returns a slice of receive-only channels of integers. Inside the function, we first create a slice of receive-only channels called outputs, with the length equal to the number of workers. Then, we iterate over the output slice, and for each iteration, we create a new channel called out. We assign this out channel to the current index of the output slice. Next, we launch a new goroutine that range over the input channel. For each data received from the input channel, it sends that data to the out channel. Finally, we return the output slice, which contains all the receive-only channels. Fan-in involves collecting results from multiple Go routines into a single channel. The diagram shows multiple workers sending their results to a combined output. The workers independently process data, and the fan-in pattern merges their individual outputs into a single channel for further processing or aggregation. Here's the code snippet for the fan-in implementation. We define a function called fan-in, which takes a variadic number of receive-only channels of integers as arguments, and returns a receive-only channel of integers. Inside the function, we first create a channel called output. Then, we iterate over the input channels using a for-range loop. For each input channel, we launch a new goroutine that range over the channel. For each data received from the channel, it sends the data to the output channel. Finally, the function returns the output channel, which combines the results from all the input channels. This code provides a basic example of how to combine the fan-out and fan-in patterns. Inside the main function, we first create an input channel. Then, we fan out this input channel to 3 workers using the fan-out function. The fan-out function returns a slice of receive-only channels. After this, we fan in the results from the worker channels into a single result channel using the fan-in function. Finally, we launch a Go routine that sends the numbers 1 to 5 into the input channel. The fan-in and fan-out patterns are useful in a variety of scenarios. One common use case is parallel processing, where you can process large data sets by distributing the workload across multiple workers. Another use case is for making multiple API requests concurrently and aggregating the responses. These patterns help to improve the performance and efficiency of your Go applications when dealing with concurrent tasks. The key benefits of using the fan-in and fan-out patterns are better performance, scalability, resource management, and load distribution. It helps to utilize multiple central processing unit cores effectively, easily adjust worker count based on load, control resource usage with worker pools, and evenly distribute work across Go routines.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.